flowchart for assume initial guess, and then you start the problem. So initially, the flowchart starts with start. Here we have to define function, given function, and derivative of that given function, and double derivative of this function. So here there are three dots, there are no three dots, only two. Double derivative of given function. So we have to go ahead. So first of all, we have to define given function, derivative of that function, and double derivative of given function. Here dd stands for double derivative. And then you read initial guess value and number of iterations. So this flowchart is drawn based on number of iterations. So next, find the value of function, derivative of function, and double derivative of function by putting initial guess value in given function. And then, so we have to check convergence criteria. This is the convergence criteria. So that is, so some value a is equal to y1 into y3. So this is y1 into y3 upon y2 square. So if this value is greater than less than 0, so then there exists a root, or this solution converges towards the root. If it is not, then we have to select new root value or new approximate value. So for that, see, once you have computed, so it goes to while loop. While absolute means it may be a negative or positive, always it counts positive value. Absolute value of a is greater than. So if it is greater than s, so then it asks read again initial guess value and repeat the procedure. Now same initial value you substitute in the function, find its value, substitute in the derivative of function, find its value, again that value substitute in the double derivative function, compute the value, and once again check for value of a. So value of a is, again, if it is greater than 1, so repeat the procedure. If it is less than 1, so this control goes out of the while loop, and for no, it goes forward. Now the next step is number of iterations. We have to perform this operation n times up to number of iterations. So here it is a for loop for value of I varies from 1 to n, for I is equal to 1 to n. If the value of I is less than n, yes, so it computes x2 is equal to x1 minus y1 by y2. Means in the previous lecture, we have not used these y1 and y2. So what we did, instead of y1 and y2, directly we have written a function. So here that function, so like this we have written, this is x2 is equal to x1 minus f of x1 upon f dash of x1. So this is the function. Say for simplicity, it is difficult to write this function in the programming. That's why. So this f of x1 is represented by simply y1. Here you can see f of x1 is equal to y1, f dash of x1 is equal to y2, f double dash of x1 is equal to y3, like this. So it is represented. Now this formula is used for computing new root value. So we have computed here new root value. So because we are setting in the loop, so what we have to do in the for next iteration, we have to use whatever value we have computed here. That value is used for computing new root value. So therefore, in the formula here we have used x2 x1, means for next iteration again this x2 becomes x1, and we have to find the value of y1 is equal to f of x1, y2 is equal to f dash of x1, and again, so you repeat this. So I value will be incremented by 1. Now I is equal to 2. So again this is less than number of iterations, true. So repeat the procedure. So thus it repeated the procedure until the value of I is equal to n or greater than n. So less than or equal to n, so it repeats. So once it becomes a greater than, so this condition fails, means the control goes out of the loop, and then it prints the root value, so that is x2, and ends the program. So this is for number of iterations. So if it is based on error, in that case, instead of this function, so here you can use while, similar to this while. So the error, say x2 minus x1 is less than or equal to 0.001. So here we have to compute new value x2 minus x1 value. So this value until it reaches to a desired accuracy level. So you repeat this procedure. Once it satisfies the condition, it goes out of the loop and print root. So only difference is, so here, so this is for number of iteration. Again, you change this for accuracy. Rest of the flow chart remains same. This is for accuracy. Either accuracy simply, or you can use relative percentage error. You write here relative percentage error formula, accuracy formula, and absolute error. You use absolute error formula, number of iteration. So already it is written for number of iteration. So thus only change occurs here, whatever may be the type of program. So only it depends upon the truncation criteria. So you can use appropriate terminology here, and the rest of the uh, program or the rest of the flow chart remains as it is. Either it belongs to accuracy, it belongs to relative percentage error, or it belongs to absolute error, and so on, number of iterations. So only there will be a change in this block. So you change this block accordingly, so you will get program for particular thing. So this is about the flow chart for Newton-Raphson method.